Okay, so hello and welcome to this next lecture in the ongoing series of lectures on printing inks. Till the last lecture, we had completed our discussion on what colorants were and different types of colorant. I had showed you pigments and dyes, and I also showed you the comparison between the various colorant, what is the use case of these colorants, in which type of inks they are being used. All these things I had shown you. In this lecture, we will move on to the next raw material, the component which is used for preparation of printing ink, that is especially for pasting, used for your offset application, that is oil. Oil can be classified into as initially I told you, if I remember, in the second slide itself I had showed you one comparison, right? If you remember correctly, that not comparison, sorry, classification, that how inks are basically classified based on the types of vehicle system. So I had told you that the oleoresinous vehicle systems, they are responsible for creation of this your mm, pastings basically, and your solvent and colorant systems, they are used for creating your liquid inks. Now that oil is basically part of that pasting itself. Here we have classified oil in three categories primarily. One is the drying oil, non-drying oil, and semi-drying oil. Let me give you a very brief idea about what it all means. For drying vegetable oils, normally drying oils are vegetable oil only. What happens is, drying oil, whenever we are using this in a particular ink, then this dries with the help of this component of this drying of vegetable oil. They dry with the help of aerial oxidation, which we also call as oxidative polymerization reaction. Okay, I referred to in earlier lecture also. Now, not these vegetable oils are having higher viscosity, so naturally they cannot penetrate within the paper, so they will remain on top of the ink layer only, which is being printed. So how will they dry? This takes a lot of time because they dry with the help of oxidative polymerization, which is accelerated, or which is, you can say, initiated also with the help of the dryers, those cobalt and manganese. I'll show you that complete reaction I will show you. Okay, so that this is the function of the vegetable, I mean drying oil. Then we have the non-drying oil. Non-drying oil are normally we are using this mineral oil based non-drying oil. There are vegetable oils which are non-drying also. Now, what is the quality of this non-drying oil? They do not dry by aerial oxidation. They dry with the help of penetration into the paper. So they get absorbed into the paper and therefore they dry. And semi-drying oil is somewhere in between. They have both type of nature. Their viscosity lies somewhere in between the two oils. Okay. So now let us understand that why I am seeing this drying oil, or this drying vegetable oil. They are drying with the help of your this thing, oxidative polymerization, or oxidative polymerization, or aerial oxidation, whatever you like to call it. Okay, so let us take a look. See, essentially oils, these oils are essentially nothing but fatty acids, right? Now you can have two types of, structurally you can have two types. They're all linear structures actually, but you can have, they may be branched also, doesn't matter. But ultimately what is, for non-drying oils are saturated fatty acid. That means saturated means there is no unsaturation within the carbon-carbon bonds. But in case of your drying oil, there may be multiple such unsaturations. Okay, and the reason is why the viscosity is high. From this concept you will be able to see, whenever there is this unsaturation, what happens, because of bulky groups, functional groups are present around this unsaturation, they tend to change the structure of the branch or the chain, as a result of which, because these bulky groups are present, the viscosity of these oils are quite high in comparison to your non-drying mineral oils. Okay, what happens is, I will show you when we will study about dryers how that reaction, what happens is, this unsaturation is responsible for this oil to dry up. Ultimately dryers are the initiators, you can say, are providing initiation to the oxidative polymerization reaction. And through a chain reaction, polymerization reaction, these unsaturations are converted into saturations, carbon carbon single bond, within the entire fatty acid chain, and all when all these double bonds have been saturated, the oil dries up. That means it gets polymerized. Okay, and if something get polymerized, automatically it will dry up and it will form a large film type of a structure. Okay, so that is the source of this unsaturation is the source of the drying oil basically. All right, now or why these vegetable oils are known as drying oils basically. Okay, next, this is most vital, most important part of the ink part, I mean the ink chapter, which is the resin. Resin, I told you, this is the heart and soul of the ink. Most of the properties of the ink, that is the solvent uptake, water emulsification ability, your optical properties, your adhesive power of the ink onto the substrate, all these things, surface properties, all these things are primarily controlled. Again, I'm repeating, primarily controlled by the resin. Why primarily? Because it is the resin and the resin choice that you are making which will drive these decisions, or which will ultimately drive these properties, okay, of the ink. So if you say that you are using a particular resin which is not providing a very good in the ink, and the ink after printing you see that you are not getting very much good addition. So I faced one, because I'm also from the ink industry. I faced a problem once, that is some customer was printing on ice cream cup, the outside of that ice cream cup. So normal, and it was dry offset UV based printing. So after curing, UV curing actually, the ink was not adhering well onto the substrate. That is the, I think it was PP material substrate. So we tried to increase the surface property, but ultimately, no matter how much you add, uh, these type of additives onto the ink, the only way to ensure that you get very good addition is to control your resin. You can modify your surface properties, you can modify your wettability, all these issues you can modify with the help of some additives, that is true. But the basic fundamental which controls or which drives your entire ink chemistry is the resin. Resin is, that is why known as the heart and soul of the ink. Okay, so as we go ahead, we'll see how all these factors come in, and why all these things come in, and all these things we will be studying. Okay, now see, resins can be classified into two categories. One is natural, one which is synthesized. Okay, the most naturally occurring resin, which is often used as the basis for preparation of other resins, modified resins in in chemistry, is known as rosin. So I will not show you all this thing, but let me just go and show this thing itself to you. So that is the most naturally occurring resin in that is obtained from the trees actually. That is known as pine trees, bark of pine trees and all this. So this is known as rosin. Rosin contains the many acids actually, but the primary acid which constitutes rosin is abietic acid. The structure you can see in front of you is known as abietic acid. There are other acids also, fumaric acid, levofumaric acid, isofumaric acid. All these acids are there, but primarily what rosin contains is this abietic acid. Okay. Now normally anything as with anything natural, it may be very good, but it may not be very much suitable to uh, completely control all the characteristics of the ink that you want. Maybe you'll see that gloss is very high for a particular ink, but then setting time, okay, setting is like I don't know if I have told you this before or not. I will be talking about this here itself, in this chapter itself. Setting is how quickly the ink, uh, the non-volatile part basically, the volatile part basically, or the low viscosity component of the ink that penetrates within the paper, that is known as the setting time. So it Setting and drying are two distinct terms, so you have to distinguish between the two. So just for a consideration, let us consider that this particular ink that we are making with rosin may have a very good gloss, but then the setting is not right. So naturally it is required for the ink maker to use rosin as the basis for preparing some other modified resin for the ink manufacturing. That is why now we modify rosins with the help of very many other chemicals to create new resins which have got good properties, overall good properties or specific properties. In case of UV chemistry, UV ink making chemistry, we'll see there are this concept of monofunctional monomers, bifunctional monomers, multifunctional, all this. So one particular material, one particular resin may control one property or one or some other property, but it may not control or it may not give you the perfect property in all respect. So that is why it may be necessary sometimes to use more than one resin in particular ink. And naturally we can modify resins and we can modify rosin to create some other resins also. So here you see alcohol has been one type of alcohol. It's a very common type of resin that I have shown. So this alcohol is not used. Normally what the alcohol that is used is pentaerythritol. So this is a very, just for example I have shown you, this is not the chemistry. So ultimately when you use the alcohol, when you modify the rosin with an alcohol, what is rosin acid? So ultimately what you get is an ester, right? This reaction, there are very long chain of reactions that takes place. Transesterification is the ultimate step, and esters is created through condensation. Actually last step is condensation and then esters are created. This type, whenever we are modifying rosin with this type of alcohol materials, alcohol chemicals, then or alcoholic functional groups, then the resulting resin that is created is known as rosin modified ester. That means what? The ester, which is this one, this ester has been created, but created how? Through modifying this ester with the help of rosin. We have modified rosin in such a way to create this ester. That is why its name is rosin modified ester. Another example is very common example is malic anhydride. Malic anhydride, when you, this phenolic acid, as I told you, phenolic acid is also obtained in rosin only. So when you react malic anhydride with phenolic acid, the resulting resin that you get is known as malic modified rosin. That means rosin has been modified with malic anhydride. Okay, this is another form of resin. Don't worry, I will not ask these formulas and these structures in exam. This is just for showing you the very basic fundamentals, because you are going to be a printing technologist. You are not going to be a chemist. So we are not expecting you to learn all this and do some chemical reactions and create new this resins and all. Just basic fundamentals should be known to all of you. Okay. So there are two books I normally say to students. There are two books in ink chemistry. One is the ink manual, but the ink manual is not for us. Ink manual is for the ink makers. Okay, ink manufacturers. The book that suits us best is, I think it's a very good book from GATF or something. What the printer should know about the ink. Something like that. What the printer should know about ink. That's the book we should follow. That's the book we should study. But ultimately, as per syllabus, your textbook is Madam's book, TD Madam's book, that is Chemistry in Printing. That is a very nice book, nice compendium that provides all the information that is necessary for you to be aware about fundamentals in ink chemistry. No doubt about it. Okay. So yeah, this another very popular resin here. You see again that ultimate reactions, most of the reactions, final step is the condensation reaction. So here you see phenol formaldehyde together are being used to to create a new resin which is known as synthetic phenolic resin. I think you are well aware about in I think in class 11 or 12 you came across all these reaction mechanisms and all. But here in this particular case, you see the linear polymer that resin that has been created, that has been created with the help of some modified phenolic resin. Okay, so this is another very popular example of resin that is being used. Another very popular example is that Here you see this is known as rosin modified. So when rosin is modified with the help of a phenolic resin, then ultimate. So you might ask that why in all the cases, because this ultimate formulation that comes about when you create this phenolic modified rosin modified phenolic resin, that is so large that I could not accommodate that within a single page. So that is why I gave you this image. uh, I don't know if this reminds you of something. Looks like michri, that in when we were little, we used to have in glass containers, glass bottles. You used to mix it in water for sweeteners, essentially sweeteners, sugar sweeteners. So it appears exactly like that, like these crystals, kind of dull crystals. Okay, that is how it looks. So this when rosin is modified with the help of some phenolic resin, the resulting uh, compound that is created, that is known as rosin modified phenolic resin. That is also a very popular type of resin that is being used. Yes, this another type of resin that is used, that is known as alkyd resin. Now what happens is, so this formula is given over here when pentaerythritol, phthalic anhydride, benzoic acid, fatty acid all together leads to the formation of. That is not important. What is important is the purpose of alkyd resin. I will talk about it in great detail when we start studying about the formulation part, because now the question is, why studying formulation? It is essential. Let us say sometimes you are in the print shop, you are running a print production floor. What type of ink you need for a particular job. Let us say you are going for a packaging job, the next day you are going for a publishing job. Both the inks will not be the same quality, right? You need different types of ink. For that you should have a very basic understanding of ink formulation also. Otherwise, how will you make the judgment that what type of ink should I use? No, that is one thing. So alkyd resin is important. This is another family of resins which is used almost in all your film in chemistry, which imparts good wettability to the pigment by the vehicle. Okay, so when we go there, we will be studying about all this. Okay, another very useful resin that is used is polyamide resin, containing this amide groups there. And so polyamide resin and this all these things, they are used in liquid inks as well. Okay, so resins can be used in different types of ink, does not matter. What matters is how you are preparing that resin. If you are cooking it in oil, it will be used in offset. If you are using it in dissolving it in solvents, then it will be used in liquid ink. So like that. Okay, when we study about the manufacturing process, then it will be clear. Let us now get our idea about individual components which goes into making of any ink for that matter. Here you see solvents. The most commonly used solvent in almost all the inks is hydrocarbon, maybe either aliphatic or this aromatic hydrocarbons. They are only used in gravure films. Now I mean BIS has already banned this toluene from ink making, so toluene is not used. So these type of aromatic solvents, they are used only in gravure ink production. The concept of non-toluene, non-ketone, non-toluene, non-ketone, NT, these type of, because they are harmful for the human body. So these type of, and during the ink manufacturing also, as well as during printing with inks which contains toluene or ketone, it is harmful for the people who are inhaling it, the people who are in the production floor. So there are various side effects. So that is why more ink manufacturing companies, especially the most reputed ink manufacturing companies, they have completely moved to this concept of NTNK inks, non-toluene, non-ketone inks, which is good for the environment, which is good most essentially for the human health. Uh, and there are tendencies, no matter what type of polymers you are using. So through paper, obviously your ink will migrate into the material which is inside. But for even for polymers, it has been seen, there are studies, it has been seen that the ink has certain tendency to migrate, especially the solvents will try to migrate. And if these solvents, harmful solvents, migrate within the material which is packaged inside, and let us say some of it, substantial quantities of it gets inside, then it will be difficult or harmful for the human consumption also. So all types of care should be taken whenever you are using the raw materials for ink making, especially when it is something for packaging of which is meant for human consumption. So this toluene, xylene, these type of aromatic solvents, they are used for gravure. Now it is not used for, although aromatic compounds, some of the aromatic compounds are used for in sorry, this hydrocarbon compounds are used in making of flexo inks also, but your this toluene, xylene, these aromatic compounds are not used. Can you tell me why? I will show you that later on, but can you tell me why? That why am I saying that aromatic solvents can be used, or were used till today, I mean till now, in making your gravure inks, but the same aromatic compounds cannot be used for preparing liquid inks which is meant for using with the in flexo production. Why is that? Can you tell me? I will give you the answer in a later slide. Okay, so then we have the aliphatic hydrocarbons. Aliphatic hydrocarbons, they are used for the high, I mean non-volatile type of aliphatic hydrocarbons. They are used in lithographic, I mean offset ink making. So we will see why these types of hydrocarbon, I mean aliphatic hydrocarbons are used. But the low, I mean the volatile types of aliphatic hydrocarbons, they are used for screen printing ink making. Okay, because they are also screen printing ink making. They dry with the, because they are uh, 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 used for printing on non-absorbent surfaces like plastic and all this. That is why they dry with the help of evaporation. Okay, right. Next, other type of solvent is alcohol. Then we have okay, yeah. So all these alcohols are there. Then we have glycol. So certain glycols are safe for human consumption, not all. Just refer to the textbook for what is the exact purpose of which type of, that I have not given over here. It will become, I mean, unnecessarily very lengthy. Then we have got ketone. So here it is written itself that why these ketones and these aromatic compounds are not used in flexo, because you see flexo is using, as I've already told you in the image carrier preparation class lecture, that flexo uses rubber plates. And this ketone and these aromatic compounds, they have a tendency to swell up the, they penetrate the rubber surface and they swell up the rubber, so that destroys or deteriorates the condition of those rubber plates. That is why these, you cannot use these ketones and these aromatic solvents in flexo ink making. Okay, and then we have ester. Ester have got high migration. Migration means, I will talk about migration at a later stage, but basically migration is the tendency of the solvent component of the ink to get to penetrate the packaged surface and enter into the packaged material. So you know, you have a fair bit of idea about various types of packaging, like primary, secondary, tertiary packaging. So let us say you have a this health drink powder, any popular health drink powder you buy, those mono cartons, not those uh, you know those pp containers, but the mono cartons. So what is the primary packaging there? The primary packaging is the foil, which is enclosing that powder. The secondary packaging is the mono carton itself, right? And what is the tertiary packaging? Tertiary packaging is when, let us say, 10 such mono cartons comes within a corrugated box. So that is the tertiary packaging. We only get the secondary packaging. So we will say that foil is the primary packaging and this monocarton is the, I mean paperboard is the secondary packaging. So when, let us say that your monocarton is printed, if the ink with which you are printing the monocarton or the paperboard has the tendency, the solvents within it, not the ink, how can the ink penetrate and go into the thing, but the solvents especially, that is the problem. And that had happened in the past. I cannot name the product, but definitely that has happened in the past, and it had caused a huge, you know controversy in the past. So if you are aware, you would know what I am referring to. So this type of things happen, and there is a tendency to kind of, for the solvent component of the ink to, you know penetrate the layer of the monocarton, I mean the paperboard, and enter into the material which is packaged inside. So luckily, not luckily, by design, actually by choice, even if this happens, there is the foil which will protect the powder which is present inside, right? So that is what migration, ink migration is all about. We will be talking about that also. Yes, so next we have what is the additives. I talked about various additives. Now, what is the first additive that we talked about is plasticizer. I already told you that the these different classifications of additive, these plasticizers you can see from the textbook. That is not important. I mean, that is not really the uh, topic of this discussion. Really, I don't expect from you to memorize the names of chemicals and all this, because that is not the outcome of this course. Frankly speaking, that is not the outcome of this course. Okay, so maybe I was also supposed to memorize all these names of the chemicals and all, but that is not really, that does not meet any purpose, especially for a printing technologist. What will I do by remembering the name of a stearate or a phthalate plasticizer? What is the purpose? Useless. There is nothing. But what you need to know is the purpose, when to use, and when to be informed about if something goes wrong, how to analyze the problem. So, as a print technologist, your one of the primary function, one of the primary job responsibility in the production press, I mean the production floor, is that if something goes wrong, then identify what went wrong, and not only that, reach to the cause of that problem. So what we call as the root cause analysis, right? And then find out solutions. So in order to find out what went wrong, first of all, and why something went wrong, you need to have a very good understanding about the basics, especially this one. So the role of plasticizers I've already told you before itself. That is, this is not used for this your pastings. They are mainly used for screenings, where you will see that this concept of solid and liquid phthalates will. Phthalates is a group basically. So when solid phthalates are used primarily in for making screen printing inks, because that nature of the rheology of the screen printing ink is paste in nature. Okay. But in case of your liquid ink, obviously it is required. These plasticizers are required, but for your offsetting it is not required. Why? Why is it required for liquid ink and this screen printing ink? Because think about the surfaces on which you are using screen printing ink and liquid ink. Maybe you are printing a chips packet. So that is a, let us say that is a BOPP maybe. You're printing on BOPP. Then that is flexible, and normally it will be flexed during manufacturing process. So naturally the ink film layer will also undergo some deformation. Now if your ink film is not flexible enough, then under that deformation force, it will crack, right? In order to prevent this from happening, plasticizers are added. Why then, in case of your screen printing inks? Screen printing, let us say coconut oil bottle, those PP bottles of coconut oil, there is a curved surface that is printed using screen printing inks. Now, if you are printing, but after drying, it is, since it's a curved surface, if you are not using plasticizers, then naturally what will happen, it will kind of it may break off or it may crack. So you need to prevent this from happening, or to kind of give the dried ink film sort of flexibility. Plasticizers are added in liquid inks and your screenings. All right. Next, we have got wax. Yes, wax is another very important. I told you already that wax improves the surface property. When you add wax during the manufacturing process in ink making, the resultant ink, when printed on a surface, will have very good surface property. Will have some sleep property. What we call is the sleep, that is calculated with the help of some equipment, which gives us the COF, that is the coefficient of friction values. So I'll talk about it later on during the testing phase. So what happens is, let us say you have printed and you have packed some monocartons, and during transport those monocartons are stacked one upon the other, right? And during the transportation it will undergo a lot of abrasive forces, lot of jerks, lot of agitation. If the printed ink surface does not have a good surface property, does not have good smoothness, then what will happen, due to the abrasive forces, the dried ink surface may come off. That is not wanted. That is why, in order to improve these surface properties, there's one example, many other examples are there. Improve this surface property, you can have these waxes. So there are classification based on the origin of the wax, like synthetic, natural, petroleum, etc. Petroleum means that is obtained from petroleum distillate actually, as during the fractionation distillation process of petroleum. That is what. Okay, next we have got the dryer. I will talk about the specific type of dryer. I mean, sorry, the drying mechanism the reaction mechanism of oxidative polymerization, which is initiated through the help of the dryer later on. But these are the classification. We come with the help of the liquid and paste. Liquid can be both cobalt and manganese paste, and paste is lead acetate, manganese borate, etc. Next we have got this antioxidant. Okay, now this is quite interesting. Let me talk about this for a minute here. Say your ink, I mean pasting, normal offset pasting, let us say, that is drying through what mechanism? Through oxidative polymerization. You are printing a sheet, you are keeping it for a day or two, and through oxidative polymerization it is drying, right? This is done with the help of the dryers and obviously in the presence of aerial oxygen. So you want the ink to dry in presence of oxygen. That means you want the ink to oxidize. But then, why are you using antioxidant in the ink? Can you think about it? Antioxidant is just the opposite, will have just the opposite effect to that. It will prevent the ink from drying. Ink was oxidized, so to say, during the drying process in presence of aerial oxygen. But when you are adding antioxidant, then it will prevent the ink from drying really. I am saying to you that for offset ink making, you require both the things, that is, both dryer as well as your antioxidant together. The purpose of antioxidant is to prevent the ink from drying. This is completely antithetical to the purpose of the dryer, which is I've already given in the ink earlier. So then why is it required? You see, in offset, any offset printer for that matter, the ink has to travel quite a long distance, that is from the ink fountain to the plate, through around 14 metering rollers, right? Now, we don't want the ink to dry when it is in the ink fountain or when it is traveling, that is when it is on the ink passing through the ink metering roller. It is in contact with air, there is aerial oxygen around. So there is a chance that the ink will dry if it is kept for quite a long period of time on the ink fountain. We don't want that to happen. So if that happens, the ink will get dried up, polymerization, oxidative polymerization will happen, and that ink will be rendered useless. You cannot print with that ink. In order to prevent this from happening, some amount of antioxidant is added to the ink just to prevent that. So it's quite interesting for here to understand that the purpose of your ink and your purpose of this dryer and your antioxidant are completely opposite, but both are required at the same time to do just the opposite work. So this optimum balance between the dryer and antioxidant combination is quite essential. Okay, so what I will do is I will refer to one of my papers that I had co-authored earlier. So I will share a link so that you can read that paper, and it's in the web, free of cost, available in the web. So I will share that link. You read about it, you will get a fair bit of idea about what I'm talking about. Okay. Next, very important concept is the chelating agent. Chelating agent is this is actually not really used during ink manufacturing, but this is used during the cooking process, that is the vehicle manufacturing process, when the resin is cooked in that oil, that drying oil that is being used. So there, in order to modify the rheology of that vehicle depending upon the requirement of the ink, these chelating agents or chelates are used so that it enhances the rheology. Then we have got what? The surfactants. Surfactants, again, they are used in ink making in order to make these pigments more susceptible to being attached onto their surface by the vehicle. So if the pigment particles, I've already told you before during MQC lab also, when we were testing our Hegman gauge, there also I have told you that the pigment particles should be evenly coated throughout itself with the help of the vehicle, and it should remain very well dispersed within the vehicle, that is the dispersion medium of the ink. If it does not happen, then the pigment will coagulate and printing will not be properly done. So that is why these surfactants are added, which adds a preferential charge to the pigment particles, preferably opposite to that of the vehicle, so that the vehicle gets attracted towards those pigment particles and dispersion is done properly. Okay. And finally what we have is the rheology mode. These are clay basically. So I'll tell you a story once we have the this interactive class. I'll tell you about a funny story I experienced, a funny incident that I experienced with this rheology modifier when I was making one ink in my earlier labs. So these are clays. This will essentially increase the viscosity of the ink. This is done. This is added as an additive during the final stages of ink making really. Then we have a very specific type of ink, which is the UV curable ink. Okay, so what is the concept? Basically, I will tell you about the concept of UV curable ink. Um, I will show you one example. I will show you one UV cured printed package. If I have with me, I will try to show that. See, the UV curable ink means what? It is normally, it can, as I told you earlier also, it can be your gravure can be UV curable, flexo can be offset. The basic difference is that normally all these inks, especially offsetting, they dry with the help of oxidative polymerization. That means no external forces required except for heat set. Heat set requires heat from the name as it suggests. But for all other processes of offset, no external force is required to dry the ink. But for UV curable inks, whatever the process is, it will be dried only when after printing the substrate with UV inks, the printed substrate is made to pass under a ultraviolet light source. This light will start a polymerization reaction which is known as the UV polymerization. And after the end of this UV polymerization, the entire ink film will get dried up onto the surface of the substrate. Okay. So, what are the primary ingredients for any UV curable ink? First is the pigment is there, obviously that is the core colorant. Then we have got something which is known as the pre-polymer. Pre-polymers are essentially, they essentially does what your they're from the acrylate family basically, but their primary function of the pre-polymer is something, if I want to compare it with normal offsetting, then monomers, this direct reactive diluents, they have the property, they provide the property of the resins, and the pre-polymer, they are kind of the solvent actually. So then we have the photoinitiators. Photoinitiators are those which are kind of the catalysts, you can say, which starts the UV polymerization reaction. And then we have other additives like the inhibitors, the synergists, etc. One such inhibitor is the hydroquinone, which prevents the which controls the rate of reaction, rate of forward reaction. Okay, so this is the basic component of the UV ink actually. We'll be talking about the some of the properties of UV inks, but not really the core components and the the these individual chemicals. Okay, next, this is a very important slide, so I will try to explain this in some detail over here. See, 1 2 3 4, these are all different types of inks. Here also I have classified inks, but this is one of perhaps the most important types of classification based on the drying mechanism of the ink, how the ink dries. Based on that information, I have classified the ink. See, point number 1, okay, ink number 1, these type of inks are known as quick set inks. They have got two phases. One is a drying oil based phase, which is high viscosity component, and the other is non-drying mineral oil based low viscosity phase within the ink. What happens is, during the after the ink has been printed, and after the ink film has been of the substance has been printed with the ink film, what happens is setting occurs, that I was talking about earlier. What is setting? Setting is the absorption of the low viscosity component of the ink within the paper surface. Because it's low viscosity, it becomes very easy to for them to penetrate. What is left? The drying oil, that is the high viscosity component of the ink, is left along with the resin as well as the colorant on the top of the surface of the paper. That is second phase drying. That phenomenon is known as drying. Earlier, the absorption of the low viscosity components inside of the paper is known as setting. For set off not to happen, you know what set off problem is? For set off not to happen, it is most essential that the setting time for your quick set ink is as low as possible. We have one mechanism, we have one testing mechanism with the help of a proof bowl printability tester. We used to do that experiment to test the setting time of the ink at 30-second intervals. Okay, I'll show you one video, you'll be able to understand. So the question is now, how does the second phase, that is the high viscosity component, rise? That dries with the help of oxidative polymerization. Okay, now you see, why is it known as quick set? The reason it is known as quick set, because the setting time for sheet fed, quick set inks are basically used for printing in sheet fed offset machines. Sheet fed offset machine prints on relatively thicker stock in comparison to your newspaper or your web offset. So what happens is, if your ink does not have very quick setting times, set off problem will occur. That is, the ink from the preceding printed sheet will get transferred onto the succeeding backside of the succeeding sheet, which falls on top of it in the delivery stock. Okay, and that is the set off problem. So setting times in this type of quick setting should be very low, and overall setting and drying times, if you compare for this type of inks, that is very low, lower than other types of inks, other types of, let us say, heat settings, let us for example. So that is why this type of inks are known as quick set. It dries quite quickly, but the ideally, I mean, this is what ideally happens, but in reality, you see, for complete curing, for complete drying of a piece of paper, a sheet of paper which has been printed with the sheet fed offset machine, normally it takes anywhere between 24 to 48 hours. Complete drying, that means through drying, what you say. Okay, so this is the first type of drying mechanism. So this is the quick setting which is used in sheet fed offset process. Number two, here you see, this is only through, this ink dries primarily through penetration. So what type of ink this is? This is the cold setting, which is used for printing newspapers, web offset, through web offset. These are cold set. Why cold set? Because no additional heat is required to dry this ink. Normally, newspaper is quite absorptive in nature, and the liquid component of the ink penetrates immediately into the inside of the paper. But there is a problem sometimes happen if this penetration is very high, rate of penetration is very high, then show through problem can happen. That means the back side of the paper can have impression of what has been printed on the other side. So this type of offsettings, which dries primarily through penetration, and then whatever remaining solid is on the surface of the substrate, that dries through oxidative polymerization. These are known as the cold settings. Okay. Next, point number 3. Here you see, this dries primarily with the help of evaporation. So what type of inks can be drying through evaporation? Two types. One is your heat settings. Heat set is web offset, used in web offset printing of specific substrates, where heat is applied onto the printed layer of the ink substrate, and the volatile component of the ink, that is the solvent component of the ink, that evaporates, leaving behind the solid component to coalesce and ultimately to dry up through oxidative polymerization. But in case of your gravure process, you are using gravure inks to print on polymeric non-absorbing surfaces. So there is no concept of absorption there. So only drying mechanism there is through evaporation. You are applying heat, the material, I mean the solvent part is, volatile solvent part is evaporating, and then you are cooling it down so that the solid component, the resin component, binds firmly to the polymeric substrate, it dries up. Okay. Point number 4. This is how the UV inks basically dry up. See, oligomers were the pre-polymers that I referred to basically. So they are, the concept there is, you know what polymers are. So oligomers, and I wrote over there pre-polymers. They are not fully formed polymers. So what happens is when they receive this UV light, the photoinitiators release some free radicals. These free radicals attach themselves to the oligomers, and there they become very much active, or the monomers, sorry, the free radicals attach themselves to the monomers and they become very much active. Now these monomers, these active monomers tries to react with the oligomer by attaching themselves, and ultimately when one monomer attaches itself to the pre-polymer of the oligomer, then that becomes less reactive and the free radical gets immediately transferred to the next monomer. Okay, so this continues to happen, and until and unless all the monomers have reacted together with the oligomer to form a very long chain polymer, the reaction continues to occur. So the first step, that is the generation of the free radical in presence of UV light, that is known as the initiation step. The reactiveness of the monomer when it receives the free radical and attaches itself to the oligomer, this is known as the, and then it transfers the free radical to the other monomers becomes radicalized and they become reactive and they start joining the oligomers. This phase of the reaction is known as propagation, and finally when there are no monomers left in the system to attach itself to the pre-polymer, then that is the end of the reaction, which is known as the termination. So when this happens, you have a fully formed layer of UV ink onto the substrate and it has dried up. Okay, so this is the this slide is very important because this provides a holistic view about all the mechanisms through which most of the inks that we use in all of the conventional printing methods dry up. So just a summary: 1 refers to quickset, which primarily dries through oxidative polymerization, then through secondarily through absorption or penetration to the paper. Second is cold set, primarily through penetration, secondarily through oxidative polymerization. 3 primarily through evaporation, then through coalescence and surface drying. 4 only through UV curing or UV polymerization reaction. Okay, so hope this is clear. This is a very important slide. This is a very important part in the chapter. Now let us slowly and steadily come into the concept of this formulation part of the inks, various types of ink. So let us start our formulation with the inks that are used for letterpress. So letterpress dries through what? Primarily through oxidative polymerization and some through penetration, because it is mostly printed on papers only. What are materials are used in preparation of this letterpress ink? Carbon black, it's basically a pigment. Reflex blue, blue is often added to, now you may ask that it's a black pigment, so it's a black ink, that is the name of the ink is general purpose black. Then why reflex blue is used? Yeah, it's very, then if you had asked this question in your mind, it's a good question. Why? In order to increase the depth of the black, or the what we call sometimes, I don't know why it is called the jetness. We used to refer it to as the jetness of black, or some brands call them as jet black. That means ultimately what it means is the saturation of that color. Ultimately, technically speaking, the saturation of that black is quite high. In order to increase the saturation, it has been seen that when we add the blue pigment to it, especially reflex blue type of pigment, reflex blue pigment is quite tricky. I had a lot of difficulty in matching when reflex blue pigments were used in color matching functions. Okay, fine. So that is what I wanted to say over here, that in order to increase the saturation of the black ink, sometimes blue pigments are charged. Okay, then next we come to the concept of long oil alkyd. Okay, so long oil alkyd is I told you previously that resins are cooked inside of oil. So alkyd resin is one type of resin, I already told you, right? I showed you how it is prepared. Now, if the this kind of alkyd resin which you have, this is cooked in oil, but the quantity of oil is larger than the quantity of resin, that resulting varnish or that resulting vehicle. So vehicle and varnish I will use analogously. So whatever is varnish is vehicle. Okay, so don't get confused here. So that resulting vehicle or resulting varnish, that is known as long oil resin. So here what long oil alkyd is that. Okay, next we have got mineral oil. So mineral oil, why? Mineral oil is the non-drying oil. That means it will increase the, it will reduce the setting time. It will immediately penetrate and cause the setting. Okay. Then we have got the varnish. So varnish means here the vehicle. So how is the vehicle prepared? So this is the vehicle. Consists of hydrocarbon resin or modified phenolic resin. Both the things you know, cooked into a blend of linseed and mineral oil. Cooked again. So this start, I will explain what cooking is. So in the next slide, perhaps before going into any formulation, let me talk a little bit, because I'm again and again repeating that I'm cooking. So you might be a little confused what this term really is. So I will explain cooking in the next lecture. Then I will move on to describing the various other formulation for different types of things. Okay. So this is the varnish of the vehicle that is prepared with the help of a phenolic resin, and which is cooked inside of a linseed or mineral oil. Okay. So then we have got cobalt dryer and an antioxidant. Okay. So this is a general purpose black ink which is used for paste ink, obviously, as you can see, which is used for in letterpress printing operation. Okay. So hopefully this lecture was clear, because I didn't really want to get into this formulation part in this lecture. But in the from the next lecture, I will start the next lecture with the concept of, or with the manufacturing process of the varnish or the vehicle first, how resins are cooked, the entire cooking procedure inside of that oil, and then we will be studying the formulation of all the inks, that is your gravure ink, your flexo ink, your sheet fed offset, your web offset. Then we will see why multiple varnishes, why multiple vehicles are used in your in the single ink. So those concepts will be dealing about. Okay. Thank you for listening.